Hi, good day. My name is Imiji and I'm going to present about additional theory and objective. As we know that shear force is a force acting in a direction which is parallel or tangential to the section of a body, while the bending moment is the internal reaction to a bending load which is caused by an external force or a moment that is applied in a structural element. Besides, shear stress is also defined as a stress acting perpendicular to the cross-sectional area of the load-carrying members, while the shear strength is the ratio of displacement to the body's original shape and dimensions due to the effect of shear stress. Besides, a beam will bend and undergoes elastic deformation vertically when the vertical component of forces acting perpendicular to the longitudinal axis of the beam. So for the next one, there are three objectives stated in this lab report, which are to study the principle involved when determining the shear force in a beam, to investigate the shear force variation when the point load is increased, and the last one is to investigate the shear force variation at the beam's cut position for various loading conditions. That's all from me. Thank you.
Assalamualaikum and hi, my name is Jita Shikin binti Hairani and my metric card number is AA200719. So the apparatus that used in the shear force of a beam experiment in the structure's frames are hanger and messes, digital force display and securing thumb screws. Next,
in this video, I will show you how to perform the shear force and bending moment experiment. So there are two parts of experiment that need to be performed. The first part of it begins with resetting the digital force display meter to 0 when there is no load. Then 100 gram mass is suspended 40 mm to the left of the slice region. Following that, the readings from the digital force display must be recorded into the table provided. Then, we repeat steps 2 to 3 with 200 gram, 300 gram, 400 gram, and 500 gram as hanging weights, continuing the experiment from part 1. Next, we proceed to the second part of an experiment which begins with the resetting the digital force display meter to 0 when there is no load. Then, a 400 gram mass is prepared and hung at the position of 140 mm on the left of pivot point A. After that, prepare 200 gram as weight 1 and 400 gram as weight 2 of hanging mass and suspend it at a position of 220 mm and 260 mm to the right of pivot point A respectively. Then, record the reading shown by the digital force display meter. After that, prepare 500 gram as weight 1 and 400 gram as weight 2 of hanging mass and suspend it at a position of 240 mm and 400 mm to the right pivot of point A, respectively, as well as record the reading shown by digital force display meter. This concludes the procedure required for this experiment. However, don't forget to record the results of these experiments because it will assist us in achieving our goals for conducting the experiment.
Hello, my name is Eng Sao Tang. I will continue discuss about the observation of experiment 1. Before the experiment is started, the digital force display meter is set up to 0 reading with a no load condition. For experiment 1, the load is hung at the position of the lab sheet mentioned. After hanging the load, the readings are taken from the digital force display meter. After taking the readings, the loads are added to 200 gram, 300 gram, 400 gram, and 500 gram respectively. When the loads are added, the reading is increased too. Hence, we know that the higher the mass of the load, the higher shear force. For experiment 2, the specified load is hung at the position of the lab sheet mentioned. The readings are taken from the digital force display meter after hanging the load. The experiment is repeated with other specified load and position.
Assalamualaikum and hi, my name is Hanis bin Hussein and my metric card number is AA200268. Here I will present about conclusion of the shear force and bending moment experiment. At the end of this experiment, we were able to identify how shear force rates when the point load is increased. We will also observe how shear force varies at the cut point of the beam under various loading situations. According to this lab experiment, the shear force increase at the weight applied to the beam increases, indicating that the load is directly proportional to the shear force. It was also proved that the shear force acting on the cut part on the beam is equal to the force acting on both the right and left side of the cut section. While the experiment was successful, there were a few minor issues that could compromise the precision of the data accurate. The digital force display meter, for example, is difficult to set to zero when there is no load, and the load must be held by holding the load in order to obtain precise data readings. As a result, a recommendation that we can make while doing this experiment is the person who is responsible for repairing the laboratory equipment as well as establishes a fixed hanger of the load so that we only have to add the load and avoid errors. That's all from me. Thank you.